rational roots of a polynomial. To find the possible rational roots of a polynomial, you create the possibilities by using this. You take the factors of the constant term, all the factors of the constant term, divided by or over all the factors of the leading coefficient. Or we refer to this in math sometimes as what are your P over Q's. Okay? I don't know why P and why Q, but that's what we do. Okay? So, because you could begin anywhere. I mean, there are an infinite number of numbers that could work. Okay? So, first question. Find all the roots of f of x equals x to the third minus 2x squared minus 11x plus 12. So it's asking, what numbers could I put in there that when I worked it out, I would get a remainder of 0? Or when I plugged it in to all the places where there's an x, I would get 0. Okay? That's what it's looking for, the solutions to the polynomial. Okay, first of all, how many solutions am I going to have? We know this. We did this last semester when we solved polynomials by factoring. Something tells me, when you look at that question, how many I'm going to have. Caleb?
3.
3. So you look at the degree of the polynomial. The highest power is 3, which means you have 3 solutions. The degree of the polynomial, which just means the highest power, tells you how many solutions or roots you're going to have. Okay? So I'm going to have 3 answers. So I start by doing my P over Q's, because there's an infinite number of things. There's all kinds of numbers. Okay? So I take the factors of the constant term. So that's my 12. All the factors of 12. 1, 2, 3, 4, 6, and 12. And you then have all the positives and the negatives of those numbers. So you don't just have 6, you actually have 12 numbers there. Over the factors of the leading coefficient, which in this case will make it easier. We started off easier, which is an understood 1. So my factors of my 12 over the factors of the leading coefficient, in this case it's a 1, so plus or minus 1. And then I create all of the combinations. Now again, this one I'm starting off easy because everything over 1 just gives you what you have. Okay? So I have 1 over 1, which is 1, 2 over 1, which is 2, 3 over 1, which is 3, 4 over 1, which is 4, 6 over 1, which is 6, 12 over 1, which is 12. The plus or the minus value of all of those. So this means that when I go to do my synthetic division, this is the list I choose from. 7 is definitely not going to work. 11 is not going to work. 5 is not going to work. Okay? These are the 12 possibilities that you start with. Okay? There's only 3. There's only 3 answers. Okay? And it can only be, let me back up. The rational roots can only be here. You're going to build on this junior year, because by that point you'll have learned irrational roots, how to solve something using quadratic formula. So all the ones that we're going to do are rational. Okay? Ours are all rational roots, so there's no quadratic formula. Everything we're going to do is going to factor. You'll build on this a little bit more junior year when you can work with imaginary numbers and complex numbers and irrational roots. Okay? All of ours are going to be rational roots. So I set up synthetic division. 1, -2, -11, +12. And I go to my list. And you pick one. There's no magic to it. You pick one. What do you want me to pick? 4? I really don't know what it is. I have no idea. So I try 4. So my 1 comes down. Multiply, add, multiply, add. Did you already do it? Multiply,
No.
add. I had no idea. It's a little lagging today. It works. How do I know it works? Got a remainder of 0. So that means that 4 is one of my roots. Okay? So let's find the other 2 roots. Because we know there are 3. So this is where we have our remainder, my constant, my x squared. So I have x squared plus 2x plus 3 minus 3, sorry, minus 3. That would be a big deal. Minus 3, it is super lagging today. And we factor the polynomial. So again, all of ours are going to factor this year, because we haven't learned complex or irrational roots yet. I'm going to get a positive 3, or a positive 2, so a positive 3 and a minus 1. Now this time I'm not looking for factors. I'm looking for roots or zeros or solutions. So x plus 3 would give me a solution of what?
2x.
No. Think about, if x plus 3 was the factor, what would you put in that box? Negative 3. So negative 3 is the root. So negative 3 and positive 1. So my 3 answers are 4, which I put in the box, negative 3, which I got when I factored, and the 1, which I got when I factored. This is what I'm looking for the final answer, these 3 numbers. Okay? Now, Caitlin, just let me finish this thought. Caitlin threw out 4. We tried it, it worked. If somebody would have thrown out 1, it would have worked, and then when you factored, you would have got the 4. Okay, so negative 3, 1, and 4 all would work with that synthetic division. Okay, so you don't have to find one particular one for the first try. You just got to find one of the 3. Okay, go ahead.
So you take the last number. When you the first step, you're just listing out all the factors of 12.
Uh-huh.
Let's just take the last number and set it.
And then the first number. Mm-hmm. And it's always in order, so I don't ever have it out of order. So always the last over the first. Yep. Okay, so let's do another one of those. We're going to take the factors of the constant. So that's my 2. So 1 and 2 over the factors of 2. 1 and 2. The plus and minus of all of those. So we make our combinations. 1 over 1 is 1. 1 over 2 is 1/2. So yes, you can have fractions. 2 over 1 is 2. And 2 over 2 is 1, which I already have, so don't write it again. So I have 6 different numbers to choose from. 1 and negative 1, half and negative half, 2 and negative 2. I'll be very honest with you here. When I made these, I made it so that when you did the synthetic division, you didn't have to use fractions. Okay? That's not always going to be the case. When you get to junior year, okay, I made it so that when you do the synthetic division, I wouldn't try the fractions, because it doesn't mean they won't work, but I made it so that integers work. Okay? Alright, so let's set it up. So that means I'm going to try either 1 or negative 1 or 2 or negative 2. I'm going to go with, I don't know, 2? Okay. Negative 2? Did you already do it?
No,
I don't know. 2 was the popular answer. We'll try that. Okay, so 2 comes down. We multiply. We add. We multiply. We add. We multiply. We add. So positive 2 worked. Got a remainder of 0. So then I take my polynomial. And I have 2x squared minus x minus 1 Now you're gonna get fractions on this part of it. So I have, first times first is 2x squared, so 2x times x. Positive and negative, 1 times 1. That is factored correctly because when I check my outer times my outer and my inner times my inner, that's giving me my -1 half. So that makes the other zeros, we got 2 from the box. What does this parentheses give me?
-1.
Very good, -1 half. And this one, +1. So remember our shortcut from, this is from last semester actually, -1 over 2, so opposite sign, and then right over left, and then +1 over 1, which is 1. Okay, a question there? Let's go down to this one, the one with the power of 4. All right.